So NASA recently launched their latest Mars rover, Perseverance, which landed in the Jezero crater in the Red Planet on February 18, 2021, after a long 7-month journey. In a press conference where they first showed the footage of the rover landing, one of the NASA lead engineers mentioned that there was a hidden message in the rover's parachute, and internet sleuths immediately set out to crack this message. Unsurprisingly, it only took about 6 hours for a father-son duo to decode this message and post about it online. So I figured I'd try my hand at explaining the solution. I got a little bit carried away and wound up recording way too long a video, so I split it out into 3 separate videos actually. So this one will give just the answer and explain very briefly how it works. You'll need a knowledge of binary numbers to fully understand this video. I'll link above a second video where I explain binary counting in depth, and I would highly recommend checking that out first if you're unfamiliar with binary systems or need a refresher. And then I'll also link down below a third video where the original intention was to try and show how one might go about decoding a puzzle like this with a fresh pair of eyes. Of course, I already knew the answer at the time, but I kind of tried and walked through some of the motivations and thought processes you might go through. It really just wound up being me meandering for like half an hour, but I figured since I already had all the content recorded, I'd just upload it as one fairly unedited bulk. Feel free to check it out, but fair warning, it might bore you to death. Okay, let's get into this video. Alright, so over here we can see a picture of the Perseverance rover's parachute that it took on its descent down into that crater. So right off the bat, you can see that there's 2 different colors. There's this sort of white over here, and then there's this red over here. And then if you look closely, you can kind of see that there's different sections of the parachute. So there's this section over here, and it's separated by these sort of like up, down, jagged patterns. And so you can kind of extend this out. It's very obvious in certain sections, but then over here where the 2 sections are both white or both red, becomes a little bit harder to see, but you can kind of extend it yourself by drawing it like this. And so the same thing happens down here too, so you actually wind up getting 3 different sections. Okay, so over here I've gone ahead and finished the annotation, dividing all the different sections. So in the innermost ring you can see this is the first section, the first ring, this is the second ring, this is the third ring, and then on the outside we have a potential 4th ring. So now I'm actually going to switch over to a computer-generated, like, annotated image. That'll be a little bit prettier to look at. Okay, so over here we have a picture that shows the decoded message. And so what the message is it says, "Dare mighty things." And I believe this is a quote from Theodore Roosevelt, I think. I'll double check that and post it as an edit over here. But so yeah, you can see that it starts over here with the D, and then you go clockwise, dare, and then you jump out to the second ring, and you continue going clockwise, mighty, jump out to the third ring, and it's things. And then in the outside, what it is it's actually coordinates for, I think it's the JPL laboratory location. And so yeah, this is basically the message. So how did the 2 people, I think it was a father-son duo that decoded this, how did they figure this out? So actually the message is encoded in binary. And so binary is sort of these 1s and 0s you'll see oftentimes when looking at computer science, or you might just see this in like movies and TV shows. And so the way this binary strings were decoded from this parachute is all the whites represent a 0, and all these red or oranges here represent a 1. So if we look at the very first section over here with the D, if we zoom in a little bit, we see that it's white, 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 red, white, white. And so if you do that in binary, it's actually 0, 0, 0, 0, 1, 0, 0. And if we convert this to decimal, it's actually going to be 4. And so what these two figured out was this number actually represents the index of the alphabet. So if you take the list of 26 characters in the English alphabet and say that A is 1 and Z is 26, so then 4 becomes D, right? Because we have A, B, C, D, so that's 4. And then something to note over here is that there's this sort of padding of 3 bits between each successive character, so there's like a delimiter character almost, and so you can see that over here. This first section of 3, it's a little bit hard to see, but this first section of 3 is a delimiter character. Then we start our section of 7 bits marking 1 character. Then we get 3 empty bits again. Section of 7, 3 empty bits again. And this is generally true for all of the characters. They're all basically delimited by 3-bit paddings. So you can see that over here, over here. And so, yeah, you could totally go ahead and try this yourself, but I'll do one more character. So over here we get, looks like it's 6 white or 6-0 followed by a 1 or a red. And so if you go back over here and we write that down, we would get, make this a little bit bigger, so we would get 0, 0, 0, 0, 0, 0, 1. That's just equal to 1, and that's an A. And so, yeah, that's basically how this works. And one more thing to note is, so for all these letters down here, it works the same way. Just convert the sequence of whites and reds to zeros and ones, convert that to decimal, and use that as an index in the alphabet. But for the numbers up here, it works a little bit differently. So if you take a look at this 11 over here, so first we convert the numbers, or we convert the colors to the numbers, so we get light, 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 dark, so that's 0, 0, 0, 1, light, dark, dark, so that's 0, 1, 1. And I'm just going clockwise, so I'm just reading down this way. And so if we convert this, so remember, start at the rightmost position and then work your way left. So this is 2 to the 0, this is 2 to the 1, this is 0 times 2 to the 2, so it doesn't really matter, and then this is 2 to the 3, and then a bunch of zeros, so it doesn't matter. So this is actually going to be 8 plus 2 plus 1, and that gives us 11. And so that's how 11 is over here, and that would work for any of these. So yeah, that's basically all I had for this video. I would highly recommend and encourage you to try and decode the rest of the characters yourself, either using this raw image, or you could just take this already annotated image and just work it out for yourself, just to cement the understanding. And like I said, I'll link 2 more videos. The first video will explain binary counting and just different number bases. So how you can have base 16 counting or base 3 counting or something like that. And then the second video is a little bit more, well, it's a lot longer and it's a little bit more just me meandering. The motivation I had for that video was to try and sort of explain how you might go about solving a puzzle like this if you were given it on an exam or as part of some sort of competition. I feel like I had to do a lot of this in college, and oftentimes once you're given the solution, like I did, like I gave you the solution in this video, it's very like obvious. It's sort of this whole hindsight is 2020 thing. So in that third video, I try and sort of go through a trial and error process on how you might try different things, find problems in your thinking, and then go back, challenge your assumptions, and then sort of make progress that way. It wound up being really, really long, and I cut out a lot of it, and it's still like close to 30 minutes, I think. So yeah, consider yourself warned. But yeah, that's basically it for this video. Thanks so much for watching. If you found this mildly educational or mildly entertaining, please consider smashing that like button or dislike button. I won't judge. Leave a comment down below if there's a correction you can think of, or if you just want to comment supportive messages. And please consider subscribing. Thank you, and I'll see you in the next one.